Hello everybody, so today I will talk about calculus. The topic today is about ballistic missile. So now I will show you the answer. Country A wants to strike one city of country B by ballistic missile. A projectile is parabola. The distance from the starting point on country A to the target on B city is 11,000 kilometers. The peak is on the midpoint of the distance between the location of A and the location of B, and that is 7,000 kilometers. The radius of the Earth is 6,378 kilometers. What is the distance of ballistic missile after reaching the target? So now I will show you the answer. First, we need to draw the Earth. This one is about Earth. Next, I will put one point in here. This is about location A. This is about location B. So here is about A on the Earth. Here is about B on the Earth, because two cities on the surface of the Earth. Now the question they want to add this one. Because the projectile of ballistic missile is about parabola, and we know that the peak is on the midpoint between A and B. That means this one is about 17,000. So in this situation, I will convert everything into 11,000 kilometers. So I just put about 17, and the distance between A and B is about 11,000. So in the midpoint between A and B, so this one in here, just like 5,500. So I put about 5.5, and this one from here to here is about 5.5. The radius of the Earth is about 6,378. So I put about 6.378. The question they want to find the green line in here. Let's see about this one. So now I will show you the answer. To find about this one, we need to create the equation of parabola. This is so important to find the distance. So I will put about coordinates just like this. So this is about the red color to about coordinates in here. So we have X and Y, and we have 0 in here. So we just know A and B. This is about the arc of the circle. So we want to find this angle in here. Why do I need to find this angle? Because we want to find the peak of ballistic missile to number 0 in here. So that we can create parabola. First, we have 5.5, 5.5, total is about 11. So the formula to find the angle of the circle, that should be about alpha divided to 360 degrees, because one circle is about 360 degrees, multiplied with b multiplied with 2r equals to 11. So we can get alpha in here. That should be about 11 multiplied with 360 degrees. We divide to 2br, and we simplify this one. To be multiplied with 6.378, that should be about 330,000 over 1063 p, and this is about degrees. So we just find alpha in here. Now we want to find distance A and B on the red line. So we have, I will about C is about center. We have triangle ABC. So we have AC, we have CB, and we have the angle in here. So we can use the formula of the triangle ACB to find the length AB on the red line. So that should be about AB squared equal to BC squared plus AC squared minus 2BC multiplied with AC multiplied with cosine alpha. So we have BC, AC just about the radius of the Earth. This is about 6.378. Because BC and AC they have the same, that's why I put about 6.378 square cosine alpha. That's about this one. This one you got about 92.9817. So we put the square root in the both sides. We got about AP equals to the square root of this number in here. And this is approximate about 9.6427. Now we want to find the length from O to C. After we find O to C, we can calculate about from O to the peak, because we just use the radius minus OC to find this length in here. And we sum with 17 in here. So you got about the distance from the peak to the O. So we have ACP. We can find the area of the triangle ACP with two radius and this alpha in here. So the area of ABC, that's about 1 over 2 multiply with AC and CB multiply with sine alpha, and we know that area of ABC equal to 1 over 2 multiply with OC multiply with AB. So we have two formulas in here. Now we have two equations that equals together. So we simplify 1 over 2, 1 over 2. And now we want to find OC in here. About OC, multiply with AB equals to this one. So we just divide both sides with AB. We have ACCP. This is about the radius of the Earth. Alpha, that's about this one. AP, that's about 9.6727. We will got approximate about 4.106. So we got OC is about 4.1688. Sorry about this one. So we put this number go in here, and we can find the distance from the peak to this point all in here. So we have 17 plus we have the radius of the Earth, that is about 6.378. We minus about OC in here. And we got about 17.2092. So we just finished about the distance from the peak to O. Now we have AB, and we know that O is the center of AB. So we know the distance between AB, that's about 9.6427. So we can find OA, OB, just like AB divided to number 2. And we have AB, that's about 9.6427. And that's about 4.8135. So that means coordinate of B on the graph, that should be about 4.82135 and y equal to number 0. About 8, that's about negative 4.82135, number 0 in here. About the peak, this one you will got about 19.2072. This is for y. And that should be about s should be number 0 in here. Then this is about y. After we have 3 coordinates of parabola, we can create the formula of this one. So I will erase this number in here, so I don't have enough space. So we know that the equation of parabola, that should be about ax squared plus bx plus c. We know that when x equal to number 0, y equal to 19.2092. So we put s equal to number 0 in here and here. So we can find the value of c in here. So the first one you will go about y equal to ax squared plus bx plus 19.2072. Now we have 2 locations A and B. We put them to create the system of equations. So after we do this, we can find the solution of A and B. And here is about the result in here. We input A and B go in here, and we got about y equals to negative 0.826365 s squared. B equals to number 0, so we just eliminate about s, and we have 19.2072. So we just finished to create the equation of parabola. Now we can use about arc length of interrupt operation. So to find the arc length, we need to have a, b. Later that we have the square root 1 plus first derivative of y to the power of 2 ds. We will apply this formula to find the green line in here. So if we do first derivative of this one, you will get about negative 1.65273 s. Now about a, b. A, that's about from negative 4.82135 to 4.82135. So that's about the location. And we put this one go in here, and we put the square under the square root ds. If we calculate about this number in here, this is approximate about, we will go about 40.3973, or this is about 397.3 kilometers, or we can approximate this one, that should be about 40,400. And that is the final answer we need to find to the green color in here. This is the end. Thank you for watching.